Hello all, welcome to my channel. So today the topic is race around condition, which is a very important topic in the digital electronics. So we would like to understand what is the race around condition, what are the ways to overcome the race around conditions. We'll draw some waveform and try to understand the concept on this race around condition. So just to give some definition, so race around condition is when the output triggers a change in output. So let's understand what I said. The output trigger a change in output. So let's suppose the output is 1, then since there is a feedback, it will create a change in output again. So the output will become 0. Again, it will create a change in output. So that is the race around condition. Your output is not getting stable. So that is the race around condition. And it occurs in JK flip-flop. And at this stage, you can see when the clock is 1, J is 1, and K input is 1, the output is indeterminate state. It is not a stable state. So let's try to understand with this the help of JK flip-flop. So let's assume the Q output is 1 and Q complement is 0. So there is a feedback. So this becomes 1 and this becomes 0. And your J is 1, K is 1, and clock is 1. So we have a 0, 1, 1. So since it is a NAND, it becomes 1 over here. And it is a 1, 1, 1. Since it is a NAND, it becomes 0 over here. And since this is a SR NAND latch, so when the input is 1 and 0, the output become 0 and 1. So you see the output change from 1 to 0. Now as I said, the output trigger a change in output again. So when the output is 0, so now this is cancelled, it becomes 0 and this become 1. So this is again 110, so it becomes 1 and this becomes 0. So again this is SR NAND latch. When the input is 0 and 1, the output becomes 1 and 0. So it will changes like this continuously. So you see this is not a, this is the output is not getting stable. So this is called the race around conditions. Let's try to understand with the help of waveform. So I have my clock, which is a logic low, high, low, high, low, and high, and then this, and I have my J input, which is high, and K input, which is again high. So what is the output in this condition? So the clock is high, so I will take this portion only when the clock is high. So this is my clock. So as I said, when the clock is high, your J input is high, K input is high, the output becomes unstable. So it will toggle like this, 0 to 1, 1 to 0, 1 to 0. Again it will, since the clock is low, now it will follow the previous state. Again here clock is high, the output become unstable. So it will be like this. So this is called the race around condition. This we also called as a racing. And why this race condition happen? Why this race condition happen? Because the half time period is greater than the delay of flip flop. This is very important. Let's try to understand this. So what will happen? So let's understand first delay. What is delay? So you know that each gate has some propagation delay to generate the output. So when the inputs are available at the gate, it takes or requires some time to generate the output. That is the propagation delay of flip flop. And this is a half time period. So let's suppose this is my t. So the half time period is t by 2. So the race around condition occurs when t by 2 is greater than delay. So let's suppose the if the delay is greater than t by 2. So you understand, right? The delay is of the flip flop is greater than t by 2. So what will happen? The output will not be generated. So when the output will not be generated, there won't be any toggling. So try to understand, right? And just for example, you say that the delay of this flip flop is 4 nanosecond. So t by 2 should be greater than 4 nanosecond. Okay, to attain the race around condition. Now, how to overcome this race around condition? What are the ways to overcome this race around condition? So the first way is very much clear. Your t by 2 half time period should be less than the delay of flip flop. That is very much required. So you already understood this delay of flip flop. Other is you use a edge trigger. You use a edge trigger. So you know that there are two type of edge trigger. So positive and negative. You use a edge trigger. Other is use a master slave flip flop. So by that you can avoid the race around conditions. So these are the way to overcome the race around conditions. Please comment if you have any query in the comment section. I would like to answer. Thank you.